Alright, so I'm gonna go over a much faster way of Gaussian-Jordan method. My other video, I went over the Gaussian method 3x3 from scratch. Here, I worked it out myself and made sure that my work is correct. And I'll tell you this, if you make a silly mistake on one step, whether it's just plus or minus sign, you're gonna get everything wrong. So it can be very frustrating. So try not to do multiple steps ahead. Just work one at a time. I know you're gonna have more paper than, but it's totally worth it to do one step at a time. So here is my explanation. So first you have to write the arguments in the matrix. You take out only the coefficient and also make sure A's, B's, and C's and numbers are correctly aligned in the right column. Okay, so we divide the top row, R1 by -3. You get 1, 1/3, 1, and 8 over 3. So we got the 1 here. Now I need 0. So I multiply top row by 5. And once I do that, add them up and replace the row 2. That's what I'm doing here. Okay, so you guys can see I add the row 1 and row 2 and replace it on R2. And that's what this notation is telling you here. Okay, I just made it up. Okay, so textbook and other people might have their own way, but you add R1 and 2 and replace. The arrow here tells you I just replace on row 2. And yeah, we got 0 here. So I need 0 here as well. So I multiply top row by 6 because -6 and 6 will cancel out and give you 0. You add row 1 and 3 and end up getting these numbers. Now next step, I multiply the reciprocal of 14 over 3. And I get 1 in the middle. So there's 1. And make sure you distribute correctly. And this is how you get. And then I need this -2 to be -2 become 0. So I multiply the second row by 2. And once I multiply everything by 2, I add the row 2 and 3 into row 3. So 2 minus 2 give you 0. 33 over 7 plus 7 give you 82 over 7. 4 minus 4 give you 0. Okay. So when you got these up to this point, things are down the hill. It will get easier. Now, we got 82 over 7. So you can multiply both sides by 7 over 82. Then you're going to get 0 and 1. So if you're doing Gaussian method, you just set z equals 0 and y plus 33 over 14 z equals 2, and then you just use the substitution method up to x. Now, so how do we do the Gaussian-Jordan method? Well, I just need to fill out the rest 0 on the upper right. So I multiply the bottom by -33 over 14 so that I can replace the row 2 with the addition of row 2 and 3. So I replace it, I get 0. So guess what? I get 2. Just like my answer key shows 2. Now the top row, for the top row, I have 1, 1/3, and 1 and 8 over 3. Order really doesn't matter, but I'm gonna start with this one. So I multiply the bottom row by -1 and add them up and replace the top row. So -1 plus 1 give you 0. 0 plus 1/3 give you 1/3. 0 plus 1 give you 1. 0 plus 8 over 3 give you 8 over 3. And the last element, I need that to be 0. So I multiply the second row by -1/3. Okay, and then add them up, R1 and R2, and replace the R1. So when you add them up, 0, add them up, you get 6 over 3, which is 2. So once you get this 1, 1, 1, and the zeros throughout, this tells you your x, y, z. So 2, 2, 0, and that's how you do Gaussian-Jordan. Alright, hope this helped you guys.